Welcome to my channel, viewers. We are discussing a few problems on midpoint theorem from class 8, lesson number 8. So let us quickly remember the midpoint theorems again. Say for example, P and Q are midpoints of AB and AC of triangle ABC. Then we find that PQ parallel to BC and PQ equal to half of BC. Right? So line segment joining the midpoints of any two sides of a triangle is parallel to the third side and its measurement is half of the third side. And another midpoint theorem, we find that a line segment drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. That means AP equal to PB and PQ parallel to BC. Therefore, AQ equal to QC. That means PQ bisects AC. Q is the midpoint of AC. Now using these theorems, we will try to prove a few sums here. So let us see in question number 1. ABCD is a trapezium. AB parallel to CD. BD is the diagonal and E is the midpoint of AD. So that means DC parallel to AB here, and you are given that DE equal to AE. That means D is the midpoint of AD. And a line is drawn through E parallel to AB. That means EF parallel to AB. These are given conditions, right? These are given. Now we have to prove that F is the midpoint of BC. To prove that BF equal to FC. That means EF bisects BC. Right? So we will try to use the midpoint theorem here. Now we know that a line segment drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. So this line EF is drawn parallel to AB and EF will bisects BD. That means this part equal to this part. So let us say this point is O. So DO equal to OB. Right? So using midpoint we will write that a line drawn through midpoint of one side of a triangle bisects third side. Right? Therefore, in triangle ADB, DE equal to AE and EO is parallel to AB, right? Since EF parallel to AB. This line EF is drawn parallel to AB, so EO is parallel to AB, therefore DO equal to OB, right? DO equal to OB. Now let us come to this triangle DBC. Now you see, now in triangle DBC, O is the midpoint of BD and OF parallel to CD. Right? Why OF is parallel to CD? Since EF parallel to AB, AB parallel to CD, ABCD is a trapezium, AB parallel to CD, therefore OF parallel to CD. Right? Two lines parallel to the same line are parallel to each other. CD is parallel to AB and AB is parallel to OF, therefore OF is parallel to CD. You see, now in triangle DBC, O is the midpoint of BD and OF is parallel to CD. Therefore, by midpoint theorem, we say FC equal to FB. FC equal to FB. Or we can say CF equal to BF equal to half of BC, or F is the midpoint of BC. Right? That was to be proved. Now let's come to next question here. You see, in parallelogram ABCD, E and F are midpoints of the side AB and CD. This is the midpoint, CF equal to AE. So that AF and EC trisects diagonal BD. AF and CE trisects diagonal BD. That means this part equal to this part equal to this part. Right? You are given that ABCD is a parallelogram and E and F are midpoints of the side AB and CD. Now let us see in triangle DQC. So first of all, you will write what are given conditions here. ABCD is a parallelogram. That means opposite sides are parallel here. CD parallel to AB. Right? Then AD parallel to BC. It's a parallelogram. Opposite sides are parallel. DF equal to FC. AE equal to BE. These are given conditions. Right? To prove DP equal to PQ equal to QB. Right? That means these two lines AF and CE trisects diagonal BD. Let us prove this. You consider the triangle AQC. You see? AQC. Not AQC, DQC. DQC. You see? F is the midpoint of CD. Right? This is the midpoint. And this line is also parallel to QC. Why this line is parallel to QC? This is a parallelogram. First, we will prove that AFCE is a parallelogram here. CD equal to AB given, right? Therefore, half of CD equal to half of AB. Half of CD means CF equal to half of AB means AE. Right? So CF equal to AE. Also CF is parallel to AE. Therefore, in quadrilateral AECF, therefore quadrilateral AECF is a parallelogram. Right? This is necessary and sufficient condition. If in a quadrilateral one pair of opposite sides are parallel and as well as equal, then we can say it's a parallelogram. Now in quadrilateral AECF, one pair of opposite sides AE parallel to CF and AE equal to CF, so it's a parallelogram. Right? So if it's a parallelogram, we can say therefore AF is parallel to CE. Why? Opposite sides of parallelogram. Opposite sides of parallelogram. right? Now let us come to this triangle, DQC triangle. This is point intersection is P. Now you see CQ is parallel to PF. CQ is parallel to PF. Why? CE is parallel to AE. So in triangle DQC, CQ parallel to FP. Why? Since CE parallel to AF. CQ is a part of CE and FP is a part of AF. Therefore, CQ parallel to FP. Also, DF equal to CF. F is the midpoint. Now, in a triangle, a line segment drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Therefore, FP will bisects DQ. Therefore, FP bisects DQ, right? FP bisects DQ, or DP equal to PQ, right? FP bisects DQ. Now let us come to this triangle ABP. Again, in triangle ABP, you see AP parallel to EQ. Why? Since AF parallel to CE. AP is a part of AF and EQ is a part of CE. And AE equal to EB, right? So you see in this triangle A, B, P, this is Q and E. E is the midpoint and this line EQ is parallel to AP, right? EQ is parallel to AB. So line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Therefore, PQ equal to BQ, right? So let us, this is 1, considering this is 1, this is supposed 2. From 1 and 2, what can you conclude? You say DP equal to PQ equal to BQ, right? DP equal to PQ equal to BQ. That is, we can say AE or AF and CE trisects BD, right? These two line trisects diagonal BD. So this was to be proved. Now let's come to question number 3 here. ABC is a triangle right angled at C. This is right angle. A line is drawn through the midpoint M of the hypotenuse, which is parallel to BC. That means MD parallel to BC, right? Now to prove that AD equal to CD, AD equal to CD, that means this particular this part, CM equal to AM equal to half of AB. So you are given angle C or ACB equal to right angle 90 degree. You are also given AM equal to, M is the midpoint, right? AM equal to BM, right? Or also you are given that MD is parallel to BC. Now let us prove these things. AD equal to CD. Now we see in triangle ABC, M is the midpoint of AB, MD is parallel to BC. So a line segment drawn to the midpoint of one side of a triangle parallel to another side bisects the third side, right? So M is the midpoint and this line is drawn parallel to BC. So this line MD will bisect AC. That means AD equal to CD, right? A line drawn through midpoint of one side of a triangle, midpoint of one side of a triangle parallel to another side bisects the third side, right? Therefore, in triangle ABC, AM equal to BM, BM, and MD parallel to BC, therefore AD equal to CD. That means first part is proved. AD equal to CD. Again you see MD parallel to BC. AC is a transversal. Therefore, angle BCD equal to angle MDA equal to 90 degree. They are corresponding angles. Right? It's a transversal. CA is a transversal. This is M. This is B. BC parallel to MD, and these two angles will be equal. Why? They are corresponding angle. So that means MD parallel to perpendicular to AC. Since MD makes right angle with AC, so MD is perpendicular to AC. Now let us come to the third part. Now you see in triangles MDC and MDA. In these two triangles, see a CD equal to AD. This was already proved, right? MD equal to MD. It's a common side, right? Then angle MDC equal to angle MDA. Each angle equal to 90 degree, right? Since it is 90 degree, so it is 90 degree. Therefore, triangle MDC congruent to triangle MDA. Why? SAS congruent criteria, right? This side equal to this side. This is common side. This angle equal to this angle. So by SAS congruence criteria, these two triangles are congruent. Therefore, MC equal to AM, CPCT. Corresponding parts of congruent triangles are equal. CPCT. MC equal to AM, but AM equal to BM, right? Since M is the midpoint, therefore CM equal to MC means CM. CM equal to AM equal to BM, or we can say CM equal to AM equal to half of AB. Since M is the midpoint, right? Since M is the midpoint, so CM equal to AM equal to half of AB. All these three parts are equal, so we can say twice of CM equal to, we got CM equal to AM equal to BM, or you can say twice of CM equal to twice of AM equal to twice of BM, right? Twice of BM means AB, right? This is the M is the midpoint, so twice of BM means AB. Therefore, CM equal to AM equal to half of AB. So this was to be proved. So thank you viewers for watching this video. Bye bye.